14 billion years ago, and we have no idea what happened before it, and we're still expanding as we will forever for the past 5 decades. Voyager 1 has embarked on an extraordinary journey through the cosmos, continuously delivering unprecedented insights and discoveries. Voyager to turn its camera back towards Earth, and it's what basically amounts to Earth's first ever selfie. And that picture was taken, and there was these pale blue dots. Each revelation seemed so astounding that it appeared nearly impossible until scientists meticulously analyzed the data, confirming the authenticity of these groundbreaking findings. Now, the spacecraft has transmitted yet another perplexing piece of information, validated by none other than Neil deGrasse Tyson himself. Voyager 1 has detected the presence of 500 celestial objects passing through the vast expanse of space. And this revelation has the potential to revolutionize our understanding of space exploration. Join us as we delve into the profound implications of Voyager's latest message and explore how it might reshape our perceptions of the cosmos forever. What is Voyager 1? Years ago, in a remarkable moment in history, two awe-inspiring spacecraft embarked on a journey into the cosmos, marking the dawn of the space exploration era. This pivotal moment unfolded in 1965, when Gary Flandreau, an exceptional mind at NASA's Jet Propulsion Laboratory, confronted an immense challenge. His task was to chart the most efficient path for a space probe to reach the distant gas giants of our solar system: Jupiter, Saturn, Uranus, and Neptune. Armed with nothing but a humble pencil, a cherished precision tool of engineers in the 20th century, Flandreau made a profound revelation. He realized that in the late 1970s and early 1980s, these four colossal planets would align in a rare celestial dance, creating a cosmic necklace with Earth. This extraordinary phenomenon meant that a spacecraft passing by each of these planets could utilize their gravitational pull as a speed boost, akin to being propelled by an invisible force. Flandreau's intricate calculations unveiled a remarkable prospect. What would have been a daunting 30-year journey from Earth to Neptune could now be accomplished in just 12 years, all thanks to these gravity assists. However, there was a caveat. The alignment of these planets occurred once every 176 years. Not one to let such an extraordinary opportunity slip by, NASA acted swiftly. Within a mere 15 days of each other, they launched two identical spacecraft christened Voyager 1 and Voyager 2 during the summer of 1977. Their mission, to capitalize on this rare cosmic alignment. Little did they know that these sibling explorers would go on to shatter records and redefine the space mission landscape. Now, more than 45 years since their inception, Voyager 1 and Voyager 2 continue to thrive, beaming groundbreaking data from the farthest reaches of our solar system on a daily basis. Despite its age, this spacecraft has maintained remarkable operational performance, functioning smoothly throughout its journey. However, recent events have caught scientists off guard. To put things in perspective, Voyager 1 currently resides over 14.5 billion miles away from Earth, and it has been covering a distance approximately 3.6 times the Earth-Sun distance annually. This enduring mission is a testament to its engineering and durability. However, recently, the most intriguing development is the detection of 500 unidentified objects by Voyager 1 as it ventures through space. These objects represent a profound discovery, as they are entirely new and unfamiliar to us, defying our previous expectations. One plausible explanation for this unexpected occurrence could be the spacecraft's aging components. Voyager 1's journey began in 1977, which means its circuitry is over 45 years old. In typical scenarios, one might expect such aging hardware to exhibit inconsistencies or failures. However, this hasn't been the case thus far. One of the key factors contributing to the spacecraft's enduring functionality lies in its dual redundant computer systems. Each Voyager spacecraft boasts two sets of command computer subsystems: the Flight Data Subsystems, FDS, and the Altitude and Articulation Control Subsystems. This redundancy ensures seamless transitions between systems and the ability to activate dormant computer components, effectively extending their lifespan. Efficiency was paramount during Voyager's mission design. To work within the constraints of power budgets and time limitations, electrical engineers developed simplified systems using hardwired logic for the spacecraft's instruments. Consequently, Voyager 1, along with its twin Voyager 2, features 6 onboard computers organized as a distributed system with 3 dual redundant pairs. This innovative approach has allowed the spacecraft to defy the ravages of time and continue delivering invaluable data from the depths of space. Power management remains a pivotal endeavor in maintaining the operational functionality of Voyager 1's computer systems. Due to the spacecraft's constrained onboard power resources, engineers have devised a range of strategies to conserve and optimize power utilization, a crucial aspect of its sustained mission. The Voyager probes are both equipped with radioisotope thermoelectric generators, RTGs, as their power source. These nuclear power supplies gradually lose about 4 watts of energy per year due to the slow decay of the plutonium they rely on. This natural decay process produces heat, which is then efficiently converted into electricity to sustain the probe's operations. One noteworthy aspect of power management involves the selective deactivation of non-essential systems. Engineers follow a systematic process to identify and power down components or subsystems that are not integral to the primary mission objectives. For instance, heaters associated with specific scientific instruments have been intentionally deactivated. While these heaters were originally designed to uphold instruments at precise temperatures for optimal performance, deactivating them significantly curtails power consumption, thereby extending the overall lifespan of the spacecraft. However, it's crucial to address the challenge of extreme cold temperatures that Voyager encounters in space. Scientists must ensure that the propellant lines remain sufficiently warm, typically around 2 degrees C. Maintaining this temperature is essential because if these lines were to freeze, scientists could risk losing their ability to accurately point the spacecraft toward Earth. Therefore, managing the spacecraft involves a delicate balance between power generation, thermal control, and operational considerations to ensure its continued functionality. Voyager 2 has initiated the utilization of a modest backup power reserve that was originally integrated as part of a safety mechanism. This backup power source will enable the spacecraft to maintain the operation of another scientific instrument until the year 2026. The safety mechanism, designed to safeguard the spacecraft's instruments in the event of substantial electrical fluctuations on board, included a limited power reserve serving as a backup circuit. This contingency power source is proving invaluable in extending the functionality of the spacecraft's scientific instruments. That said, as the power supply on the Voyager probes gradually diminishes, conserving energy becomes paramount, impacting various systems beyond the scientific instruments. One crucial system affected by this dwindling energy budget is the spacecraft's heating mechanism. Generating heat is an energy-intensive process, and as the available power decreases, more heaters may need to be deactivated to ensure the continued operation of the remaining instruments. These probes are equipped with small thrusters, which play a critical role in their functioning. Proper orientation of the spacecraft, ensuring their antennas face Earth, is essential for receiving commands and transmitting data back to our planet. Each spacecraft carries a tank of hydrazine monopropellant fuel that powers these small thrusters, which operate by emitting brief bursts or puffs to adjust the spacecraft's orientation. In the event that the fuel lines leading to the thrusters were to freeze, engineers would lose the ability to control the spacecraft's orientation and, consequently, its instruments and antennas. At that point, the probes would likely become inoperative, underscoring the importance of maintaining an adequate heat supply for the thrusters. However, there is an additional challenge with the thrusters themselves. Over time, like any mechanical system, they may experience wear and breakdowns. In 2017, engineers noticed that some of Voyager 1's thrusters were working harder to maintain the correct orientation toward Earth. To address this issue, they decided to activate a set of secondary thrusters that had been unused for an astonishing 37 years. Remarkably, these long-dormant thrusters performed admirably, highlighting their robustness and reliability. Now, the primary thrusters on Voyager 2 are exhibiting signs of wear and tear. Building on the success of reactivating Voyager 1's dormant thrusters, Engineers are planning to engage the backup thrusters on Voyager 2. These backup thrusters, though not as dormant as Voyager 1S, have still been unused since Voyager 1's encounter with Neptune in 1989, marking approximately 30 years of inactivity. NASA intends to initiate this activation. Engineers and mission planners believe that there are still several years of operational capability left in these remarkable spacecraft. This extended operational life is of utmost significance because the unique vantage point of the Voyager probes allows them to provide invaluable insights into the region of space they are currently exploring. Hopefully, the day the Voyager power down is a long time away. On that note, the decision to power down non-essential systems is not made impulsively. It entails a meticulous evaluation of the trade-offs between power conservation and the mission's scientific objectives. Engineers collaborate closely with scientists to assess the impact of deactivating specific systems on the quality and availability of scientific data. The objective is to strike a balance that maximizes power efficiency while preserving the necessary functionality to continue amassing valuable cosmic information. In addition to selective power reduction, engineers implement adaptive power management strategies that respond to the spacecraft's evolving environmental conditions. As Voyager 1 journeys farther from the Sun, the available solar energy diminishes. To compensate for this, the spacecraft adjusts its power usage accordingly. This adaptive approach ensures that available power resources are allocated efficiently to support crucial operations and data transmission. Furthermore, ongoing technical advancements and enhancements in power management techniques have enabled engineers to refine and optimize the power systems of the Voyager probes over the years. These improvements encompass more efficient power distribution, enhanced battery charging methods, and advancements in power regulation and control. Through these methodical power management strategies, engineers have successfully extended the operational lifespan of Voyager 1, enabling it to continue its remarkable scientific exploration through the depths of space. The careful allocation and conservation of power resources ensure that critical systems remain operational, allowing the spacecraft to transmit valuable data and insights back to Earth. Even though it was initially designed for a mere 5-year mission, this accomplishment is a testament to the dedicated efforts and expertise of the scientists and engineers who have worked diligently to keep the Voyager mission alive in deep space. However, it's important to acknowledge that unexpected events can still occur in the vastness of outer space. Deep space is known for its unpredictability, but even so, we do possess some level of understanding regarding the potential scenarios and challenges we may encounter. Anomaly 1 would naturally anticipate that a spacecraft like Voyager during its journey through the cosmos would primarily encounter celestial objects such as meteoroids, asteroids, and other spaceborne entities. However, the receipt of messages from Voyager 1 indicating the detection of a staggering 500 objects marked a profoundly unusual turn of events. This unforeseen development was promptly classified as an anomaly due to the signal's abrupt and unanticipated arrival, presenting the research team with a perplexing enigma. While the anomaly introduced a slight communication delay, Voyager 1 continued to exhibit its characteristic responsiveness to commands from a dedicated team at Mission Control. Notably, the spacecraft's reliable antenna remained directed towards Earth, thereby ensuring the effective reception and execution of instructions. While scientists grappled with the confounding data, Voyager 1 itself appeared to dutifully adhere to its expected operational behavior, diligently gathering and transmitting valuable scientific information. It's worth highlighting that this anomaly failed to activate any of the onboard fault protection systems explicitly designed to spring into action upon detecting irregularities. These systems, typically responsible for placing the spacecraft in a safe mode, thereby enabling engineers to conduct comprehensive investigations and diagnose issues, remarkably remained dormant. Voyager 1 intriguingly continued its mission activities without any trigger for a protective shutdown, thereby adding yet another layer of complexity to this mysterious episode. Investigating the anomaly, following a meticulous and thorough investigation, The root of the anomaly was conclusively traced back to the Altitude and Articulation Control Subsystem, AACS, which bears the critical responsibility of precisely orienting the spacecraft and managing its intricate movements. The puzzling revelation was that the AACS had been unintentionally transmitting telemetry data through an onboard computer that had ceased to function many years ago. This outdated, dormant computer, which should have had no role in data processing, inexplicably became intertwined with the telemetry transmission process, leading to the unfortunate corruption of information being relayed back to Earth. The paramount question that loomed large was whether there truly existed a swarm of 500 objects that had triggered Voyager 1's perception of a potential threat. Confirmation of this intriguing discovery remained elusive until the time-consuming anomaly could be satisfactorily resolved. The ingenious solution to this enigma ultimately involved the issuance of instructions to the AACS, directing it to redirect telemetry data to the appropriate, fully operational computer system. This corrective measure was deemed to carry minimal risk and was subsequently executed with precision and success. Nonetheless, the investigation into this anomaly posed a substantial and unique challenge, primarily due to the vast time delay in communication, an inevitable consequence of Voyager 1's staggering distance from Earth. After its extraordinary interstellar journey, the spacecraft now resides at an astonishing distance of approximately 14.6 billion miles from our home planet. Consequently, radio signals transmitted to and from the spacecraft traverse an expanse of space so immense that they require a considerable amount of time to complete their journey. This temporal chasm in communication presented a profound challenge for the mission team. Their tasks demanded meticulous planning, cautious execution of commands, and the patient endurance of lengthy periods before receiving any feedback or confirmation from Voyager 1. This peculiarity in the communication process significantly extended the timeline for diagnostic and troubleshooting efforts. Each message transmitted to the spacecraft, although subject to the arduous constraints of time, held the potential to unravel the mysteries of space and deepen our understanding of the cosmos. When NASA's Deep Space Network, DSN team, sends a command to Voyager 1, it travels as a radio signal at the blazing speed of light. The Deep Space Network is a sprawling network of colossal radio antennas strategically positioned across the globe. Its purpose is to establish vital communication links with spacecraft exploring the far reaches of our solar system and beyond. It plays a crucial role in enabling two-way communication between Earth and deep space missions and conducts radar and radio astronomy observations to enhance our understanding of the universe. This international network collaborates with various space agencies, including the Soviet, Chinese, Indian, and Japanese deep space networks, as well as the European Space Agency's ESA tracking system. By working together, these agencies create a unified and cooperative effort to explore and investigate the mysteries of space. These revelations expanded the frontiers of our knowledge regarding the intricate systems of moons and rings that orbit these majestic gas giants, offering profound insights into their genesis and dynamic evolution. Yet among Voyager 1's most captivating discoveries was the presence of active volcanoes adorning the moon Io, a celestial companion of Jupiter. Voyager 1 bore witness to the awe-inspiring spectacle of plumes of erupting lava surging skyward to astonishing heights, often reaching hundreds of miles above the moon's surface. These eruptions showcase the profound geological activity unfolding within our celestial neighborhood, painting a vivid portrait of the dynamic forces at play in the cosmos. These mesmerizing volcanic eruptions on Io are set into motion by the captivating ballet of tidal interactions that unfold between Io, Jupiter, and its other lunar companions. This remarkable revelation not only expanded our understanding of the sheer variety of dynamic processes transpiring beyond Earth, but also showcased the unique and mesmerizing characteristics exhibited by celestial bodies within our solar system. Voyager 2, Voyager 1's intrepid companion spacecraft, also etched its mark in the annals of space exploration during its sweeping encounters with Jupiter, Saturn, Uranus, and Neptune. Voyager 2 made profound contributions to our knowledge of these distant giants. However, amid the celestial bodies and their moons, Voyager 2's sojourn revealed something truly remarkable, a revelation in the vast cosmic expanse. Voyager 2 achieved a groundbreaking feat by providing humanity with the first-ever direct measurement of the termination shock of the solar wind. The termination shock marks the region where the solar wind, a continuous stream of charged particles emanating from our radiant sun, undergoes a deceleration and densification as it interacts with the boundless interstellar medium. Voyager 2's precise measurements gave us invaluable insights into the intricate structure and defining characteristics of this boundary region, thereby enriching our understanding of the intricate interactions that unfold between the ceaseless solar wind and the surrounding cosmic expanse.